Hello guys, today I will slowly quench a reaction to stop the reaction process. Then I will perform a liquid-liquid extraction to separate my organic compound from any other impurities or salts that may have been generated in the process. First, I'm going to slowly quench the reaction, and I'm going to do this with deionized water. And I'm going to quench the reaction to fully stop the reaction. So here we have a reaction flask, which is actually a round bottom flask under an inert atmosphere. First, I'm going to take the inert gas balloon away, and I'm going to insert it in this cork for safety. Anyway, I'm going to peel out the septum, and before I quench it with a good amount of deionized water, first I'm going to add a few drops to make sure that the reaction has been carried to completion and that none of the reactants are still active. A lot of times when you use air-sensitive reactants such as n-butyl lithium or sodium hydride, they react very violent with water, so you want to be very careful. So, grab a pipette and add a few drops. So we see that nothing violent has happened. Now I can add a good amount of deionized water and fully quench the reaction. Now that I've quenched my reaction, I can remove my stir bar and transfer the solution into a separatory funnel where I will separate my organic compound using an extraction solvent, in this case ethyl ether. I'm going to want to rinse this with my extraction solvent, ethyl ether. Out. Put it aside. Using a clean funnel, I'm going to transfer it to my separatory funnel. It is very important to use quantitative transferring, so hence I'm going to do that. And I'm going to do that 3 times before I can move on. And remember, part of quantitative transferring is also to rinse the funnel after you quantitatively transfer 3 times out of the flask. And make sure that the tip or the nozzle of the bottle never touches either the flask or the funnel. Now that I've quantitatively transferred my reaction from the reaction flask to the separatory funnel, I can add my extraction solvent, ethyl ether, and extract my organic compound from the aqueous phase. So now I'm going to add the extraction solvent, ethyl ether, that's called for in my procedure. The amount you add might vary depending on your procedure. Then you can see that I have an aqueous and an organic phase, and I know which one's which because I looked up the densities, and the one with the lowest density, in this case the organic solvent, should be on top. Next I'm going to cap it, and I will briefly shake it so that my organic compound comes in contact with my organic solvent, and that way I can extract it from the aqueous phase. Every time I shake it, I am going to vent the step funnel so that any gases that are formed in the process can be released. And I'm going to shake it and vent it until there's more gases coming out of the separatory funnel. I'm going to put it back and wait until the 2 phases separate again. Since I already know that my aqueous layer is on the bottom and my organics on the top, I am going to first drain my aqueous layer into a properly labeled Erlenmeyer flask. I'm going to set it aside Then I'm going to drain the remaining organic layer into a properly labeled Erlenmeyer flask as well. Now that I've separated the layers, I'm going to add the aqueous layer back into the separatory funnel so that I can run a second extraction and extract whatever organic compound might have been left in here. Depending on your procedure, the amount of extractions that you have to do may vary. And I'm going to perform quantitative transferring as well. And remember, this has to be done 3 times before you can move on. And also, once you've quantitatively transferred 3 times, you have to rinse your funnel as well. So now that I quantitatively transferred my aqueous layer into my separatory funnel, I can add more of my extraction solvent. To perform the second extraction. I'm going to cap it, remove it, shake it, and vent it. And remember, when you vent, make sure to point it away from you or anyone else in lab. So now, I will again drain my aqueous into the properly labeled aqueous Erlenmeyer. And I will drain my organic layer into the previously used Erlenmeyer for the previously drained organic layer. After I've extracted the needed amount of times, I will put the organic layer back in the separatory funnel and run a final brine wash. And what this will do is this will pull any residual water from the organic layer. And remember to use quantitative transferring. I cannot stress how important that is. Remember to do it 3 times, at least 3 times. So now I'm going to add the brine. And as you see, I've generated 2 layers again, an organic and an aqueous. So I'm going to cap it, I'm going to shake it, and vent it. Go back. I'm going to wait for the layers to separate. And I will drain the aqueous into a properly labeled Erlenmeyer flask. Away and drain my organic into a properly labeled organic Erlenmeyer flask. Once I've done so, I'm going to use the salt, in this case magnesium sulfate, to dry the organic layer. And what that will do is that will also suck up any residual water from the organic layer. I'm going to add a couple of scoops of this salt into my flask. And I'm going to continue adding salt and swirling until the salt is free flowing. Now that I've added the right amount of drying agent, which was salt magnesium sulfate, I can now filter the salt, which is the drying agent, from the organic layer using filter paper and a funnel. I will first dampen the filter paper with some of my extracting solvent before I can actually filter out and make sure that the solvent never goes above the filter paper. Otherwise, it can go around it and you might get some of the drying agent into your flask. And remember that you must also use quantitative transferring. This you must at least do 3 times before moving on. Now that I've fully worked up the extraction, I can concentrate this in the rotary evaporator. So, have fun.